Hello, I'm Michael Killen, and my guest today is Joe Stagner. He is the Executive Director of Sustainability and Energy Management for Stanford University. And I'm going to ask him a series of questions about Stanford's climate, energy, sustainability strategy. I want to take a look at how it started, the development of the strategy, the plan. What is the status right now, and where does Stanford plan to take that plan? Joe.
Pleasure to meet you, Michael.
Oh, it's a pleasure to meet you. Thank you for being my victim tonight.
My pleasure.
No one's ever a victim. Everyone seems to enjoy their time here. Now, I was wondering, when did Stanford decide to take a real hard look at climate change, maybe, energy usage, water usage at the university?
Well, starting in the 1990s, the university started a bunch of energy conservation measures in buildings, changing lighting out, putting vending misers on Coke machines, doing energy efficiency projects in buildings. So it was general energy efficiency and didn't have the term sustainability attached with it. But in the late 90s and early 2000s, as you know, the world began to see and understand better the effects of climate change and the pending problem that was presenting. And so Stanford, around 2004, 5, 6, students, faculty, staff all got together, realizing the seriousness of the problem, decided we really need a comprehensive approach to this. We really need to understand what the challenge is and how we can design and construct and operate our university in a sustainable fashion. Okay. So in 2006, they decided that the best way to do that would to take those departments at the university that are responsible for designing, building and operating buildings and energy and water and transportation systems, and put them all together under one department to facilitate good communication, collaboration, and challenge that department to devise options to do this in a more sustainable way.
Did this include the academics?
Yes, the academics were some of the great leaders that really prompted administration to do more in this, gave the administration ideas about the kind of challenges we face and the kind of folks we would need to tackle it.
Like who? Steve Schneider?
Oh, Steve Schneider was definitely part of it. And Jeff Kosseff and Buzz Thompson of the Woods Institute. Sure.
Are they gone now?
No, they're still there. They're not directors of Woods anymore. After laboring for a decade to make great progress, they've now handed over, to exactly Chris Fields and others that work. But they put in a lot of good effort, and I worked a lot with them. And they were two of the fellows I interviewed with in 2007 to come there.
Yeah. What is Jeff and Buzz doing?
Jeff's back in the civil and engineering department working on the water supply issues and research and political things he's interested in. Same with Buzz in law school and working on all of those things to help find information, share it with the world, shape policy. And
when you said to put these different factions and talent together under one organization, was that the pre-court?
No, that's what the Department of Sustainability and Energy Management. So on the administrative side of the campus, land, buildings, and real estate has the responsibility to design, build, and operate the physical campus itself. So in terms of walking the walk and having a sustainable campus, that would both be a living laboratory for academics and students to both share and educate facilities people how to do things sustainably, to test some of those things, and also to participate and learn with us how you do it in real life.
So living laboratory like Stanford's hospital. The patients come in, they meet the doctors, they meet the students, and everybody works together to get good outcome. Is that what you're saying? The same kind of attitude is?
Yes,
like
definitely.
Teaching about energy, climate, et cetera, working with everybody over there.
Yes. We've benefited greatly from working with students and faculty and staff to get their input and ideas about how to do things. They've provided great peer review of our ideas to make sure they're well grounded in economics and thermodynamics and the sciences and politics. So there's been a great collaboration between the administrative and academic sides of the university on this.
2005, I hope I'm saying that date properly, that's when the university decided to take a real serious look at the impact of climate change, energy, and started to think more and more about sustainability. And they set up this department.
Yes.
And the department is called?
Sustainability and Energy Management.
And were you the first head of it?
Yes.
Okay. And when did you become the head? That year?
Yeah, 2007. So they decided to create this new department in 2006, started the recruitment process in early 2007. It was a very rigorous 6-month process, and I joined in November of 2007.
Was it harder to get a job there to become, as opposed to being a student, get in as a student?
You know, I don't really think so. You know, I was always smart in school, but I'm not sure I would have made it into Stanford as a student, so I'm lucky to join them as staff, though.
Didn't you have a sustainability position at one of the state's universities or colleges?
I think it was similar. I was director of utilities at the University of California, Davis for 14 years. And so I had many of the same responsibilities to operate energy systems and water systems and so forth. And just like Stanford, UC Davis was starting to move in the path of sustainability, find out, you know, how can we do this more sustainable? Stanford created this new position, and it was a great opportunity to come work for a world-class institution with the kind of knowledge and resources they had to actually do something really great. And I'm glad it worked out that we were able to do something really, really great at Stanford.
So I'm fascinated with something. I have met a few sustainability directors of cities, of counties, of companies, but you, and they seem to be, those that I have met primarily are concerned with focusing on what the state requirements are and seeing to make sure the city or whatever adheres to those requirements, and helping to outreach, educate. But you also seem to have power, real power. You got the energy systems of the whole university under you.
Yes, well, I think that was very adept of Stanford management to realize that, you know, the fastest way to achieve change is to go to those directly responsible for things and ask them to find ways to do it better. Develop and bring real options that they can look at and implement. And so I had a great advantage in, you know, understanding as an engineer and manager and leader in the energy business how to do these things. And so the opportunity to come work for folks that recognize that's the fastest way to change and wanted to do it was what really attracted me to Stanford. And I think that's what's allowed us to devise solutions and move to them, you know, faster than a lot of other folks.
Okay, you say that in a very nice, positive, genteel way, but also they put you in a position where you actually have the power to implement the good ideas that you get from others and add to yourself. I mean, you have a lot of power.
Yes, well, a lot of authority goes with responsibility. So again, Stanford leadership is just really adept at that, realizing that you have to marry responsibility and authority. So if they really want some big change, then you got to give big authority to folks to make big change. So they go together.
Could I have the mission statement that you must work with?
Yes, our mission is to provide safe, reliable, and quality utility services and transportation services to the university in a cost-effective and sustainable manner. So safety always becomes first. You know, the population, our water systems, our energy systems, support of the hospitals, we must always protect human life and safety. And it has to be very reliable. You know, you can't have power going out on people and those kind of things. People want good quality, reliable service, but you want to do all that in an economic and sustainable manner. So that's our mission.
Okay. In 2005, what were one or two goals that you were encouraged to either come up with or top management?
Well, when I joined actually in 2007 to 2005, our goals were to devise ways to operate the university in a more sustainable way. So for energy, water, and transportation, develop options that executive leadership could consider, weighing their cost and ease of implementation and impact on the university, but bring them options for making the university a more sustainable place. So that was the overall goal.
sustainability in terms of energy and water.
Yes, and waste and transportation and building operations, sure.
Right, and not contributing to greenhouse gases, or
Certainly.
as few parts of gas as possible.
Certainly, certainly. And also not polluting the waters of the area, limiting the amount of solid waste, so solid and liquid waste and air waste, you know. Sustainability is about the resources you consume that are not, replenishable in the environment, and what you leave behind, the footprint you leave behind to the air, land, and water. So it's that whole environmental sustainability boundary that we look at.
Okay, so that's the past. I now have a sense of where you came from, where the university's plan has come from, and now it's the present. By the way, how many buildings does Stanford have?
We have well over 800 buildings, of which about 200 are very large buildings connected to our central energy system, and many of the other smaller buildings might be little trailers and outbuildings and so forth. But in terms of the really big buildings people are, used to seeing at Stanford, there's about 200.
Okay, you brought up an interesting term, central energy system.
Yes.
Back when you first started, did the university have a central energy system?
Yes, the university's had a central energy system ever since it was founded. It first started with a steam distribution system from the old very first powerhouse. And over time, that heat distribution system evolved to include an electrical distribution system and finally a chilled water distribution system. And by the 1980s, we had a gas cogeneration plant pumping out electricity, steam, and chilled water for these 200 major buildings. And so we've had that for quite some time.
Okay, and having a centralized system, does that mean if there was an air conditioner in building 751, were you capturing the hot air coming out, or does a centralized system mean, and at that time, you were pumping cool air or chilling the air?
So one of the 200 major buildings that's connected to that central system, it wouldn't have an air conditioner. We would be supplying its cooling and heating via underground pipes from our central energy facility. Now, many of the very small buildings would have those, independent air conditioners, whether it was a window unit or a unit on top of the roof. So it all depends on, where the building is, how far away it is from the core campus, what kind of energy loads it has as to whether it's on the central energy system. But most of the big energy users that account for probably 90% of the total energy use of the campus are in those big 200 buildings.
Is that the approach other organizations that have a campus or could
Certainly.
be defined as a district centralize?
Yes. Every university I know of in California or elsewhere has a central energy system called the district energy system. So the University of California campuses all have it. Most of the California state universities have it. Some community colleges even have it. And universities across the United States have it. Airports have it. Downtown metro areas like San Francisco and Sacramento and Washington, D.C. and so forth have it. So anytime you see a big cluster of big buildings that use a lot of energy, likely you may find a district energy system supporting them rather than having individual heaters and air conditioners at every building.
Interesting. Just an aside, you and I are doing 2 half-hour shows together. This is number 1, and then we're going to produce a second interview. In the second interview, I'd like you to help us do something. I have heard from a major energy company, one of their employees said to me, you and Stanford have the most advanced heating, cooling, electrical, water efficiency system of anybody. And maybe I did not articulate that properly. Maybe
Sounded
I left
pretty clear
out.
to me.
Okay, so in the second segment of the second part 2, I would like you to help us understand what in the world they're talking about. How could you possibly, anyone have the most advanced system in this particular area? And for me to be so lucky and to live nearby and to learn from you. So we're in the present right now. Could you share a couple of your goals right now?
Sure. So our new energy system, which we call SESI, S-E-S-I, the Stanford Energy System Innovations project, that was completed in March of 2015 and brought online. So our current goals are to continue to operate it and to make sure it delivers on its promises. So it's one thing to have a great idea and then spend $500 million to install it. You want to make sure it operates right and it fulfills its promises. So when we built the system, we installed the systems that allow us to track how it performs and to constantly look backwards and measure its performance against what we had hoped it would do and what the optimum thing to do would have been. And we've been able to prove and show our board and others through independent audits that the system is actually exceeding its expectations. So making sure the system stays reliable and fulfills its promises is the current job one. And of course, safety and quality and all those other things I mentioned in our mission are always paramount. So that's what we're doing. We're also looking, towards the future to find out what can we do to enhance the system. We had a number of ideas when we first conceived the system to make it even better, and we decided not to bite off everything at once, but rather get this core new system installed, and then it was done and we were sure it's operating good, start to then further study and proceed on with these potential enhancements to go fully down the road to sustainability.
When the university decided to invest $500 million in this new energy system, when was that? When?
The board officially approved it in December of 2011. We started design immediately in 2012. In October of 2012, we started physical construction, and 30 months later, in March of 2015, the system was operational.
Okay, and a moment ago, you said your system was audited, I guess, and you had to submit, of course, details on progress, lack of progress, whatever, to the board.
Right.
What kind of, what were some of the benchmarks? What were some of the accomplishments? And maybe you could compare it to, California has its
Sure.
goals for reducing greenhouse gas emissions, and are you tracking them? Are
Yes.
you ahead of them, behind the state, or what?
Yes, when the project was conceived in 2010 and 11, and the board approved it, it was assumed that we would be able to reduce our greenhouse gas emissions, 50 or 60%, because it's mainly an electric system that's fed by electricity from PG&E. And as you know, PG&E's electricity is pretty clean by national standards, and state renewable portfolio standard requirements are that it get even cleaner by 2030 to 50% renewables. So we knew even if we used PG&E electricity that we would have a great reduction in greenhouse gases. We also knew that we would save a tremendous amount of the campus's drinking water as part of it, which I'll explain in part two. And so that was the first thing is, are we achieving what we had promised to the board in 2011? Now, those goals for that project, as you mentioned, they put us decades ahead of state and national and international goals for climate change, for reducing our greenhouse gases. We were pleasantly surprised after the board approved this and we got to building it that we're able to get direct access to California electricity markets, and we're able to select our electricity, the kind we want. It's very similar to the community choice aggregation changes that have happened from Marin County all the way down to Santa Clara County, where communities can now choose their power. So Stanford won that right to do that in December of 2012. And so knowing that we could go out and get electricity even cleaner than PG&E's, that increased our goals for greenhouse reduction accordingly. So those were the standards we sought to meet. And the audit shows that we have exceeded those. We're a little bit more efficient overall than we thought, and we're about 10% cheaper than we thought we would be because we're able to get this direct access power. And our sustainability is also 10 to 20% better than we thought.
Okay. Do you use Constellation to get your...
Constellation was one of our first energy service providers. We recently changed and now we use Calpine. They're our current energy service provider.
Calpine.
Yes, but again, they don't necessarily supply our electricity. They're our scheduling coordinator and energy service provider, and our contract with them says that the university will decide what electricity sources it wants, and then they execute and deliver that to us.
I didn't quite understand that. They provide electricity for you.
They're basically the broker. So Stanford decides how it wants to procure its electricity, and they act as our broker and go and make those transactions happen for us.
Is it an issue for you to be able to confirm that they are providing you real clean energy as opposed to buying it from somebody in Utah?
No, it's all very transparent. So the first part, as I'll explain in the second part of our interview, is that we have directly contracted for about 53% of our electricity to come from brand new solar plants constructed just for Stanford. So we have all those detailed transactions. We have the data on how much energy is produced and put onto the grid for us to take off. And the balance of our power, which we buy off the California market, they're also able to show what its greenhouse gas content is using approved state regulatory methods for estimating that.
So that procedure is audited by somebody?
Yes. For instance, we report our greenhouse gas emissions to what's called the Climate Registry. They started in California as the California Climate Registry and went national 7 or 8 years ago. Since 2006, Stanford has voluntarily reported our greenhouse gas emissions according to their protocol. They're approved by several states and Canadian provinces to develop these protocols, and a third party audits us. So we actually use a third party to certify our emissions, and then they're reported publicly through the Climate Registry.
Good. Now, when some of my neighbors and colleagues heard from me that I was going to interview you, multiple people had a question.
Okay.
That if Stanford is so into using renewable energy, how come they don't see any solar panels on your roofs in your field?
Well, if they were to go up in the air, they'd see 5 megawatts of solar panels. So they may not have seen any before 2 years ago. But when we got the right to procure our own electricity, one of our goals was to install as much on-campus photovoltaic power as we could. So we did a full survey of all of our buildings, where our trees were, which buildings were historic and had certain roofs, and we maximized how much solar we could put on our roofs. And so we actually have almost 5 megawatts of brand new photovoltaic power put on our roofs in 2016.
Help me with something. 5 megawatts. How much would my wife and I use in a year?
That 5 megawatts is capacity, and it produces about 9 million kilowatt hours a year. So I would expect you would use about 1,000th of that, maybe 100th, depending on how big your house is. So that much solar power would provide enough energy for several hundred houses, typical houses.
Okay, and now I noticed you have these gigantic water tanks.
Right.
And so you buy electricity on the open market, and you have some contracts with solar farms, I guess, and then you have your own solar panels.
Right.
And what happens in the nighttime? Your tanks are storage, energy storage?
So 2 things. For our heating and cooling part of our energy loads, we can use electricity produced in the daytime to make hot and cold water and store it in those big tanks for release at night. It actually works just the opposite, though. Even though there's a lot of solar and renewables on the market, power is still most expensive in the daytime and less costly at night. So we still use the most economic power at night to do a lot of our work of making hot and cold water. And in the peak of the day, when the California grid is facing most of its strain, we don't use electricity from the grid. For heating and cooling, that is, we release it from our thermal storage in the daytime. It's both the most economical and it's what the grid operators want. When it comes to electricity, of course, you can't have solar power keeping the lights on at night at Stanford because we don't have any electricity storage directly. We are looking and have studied quite a bit adding electricity storage to campus, batteries and that kind of thing, for that potential future. But we don't have batteries on campus yet.
So it's a strange thought to a lot of people, and correct me now, that you have these gigantic water tanks, and they really are loaded with energy.
Yes.
And in the daytime, you're using some of that water. I guess you're letting it out, and it's going places, and maybe it's turning things or affecting other things, and it's making electricity.
No, the
No?
water does not make electricity.
The movement of it?
No.
Or the heat?
No, what we have is cold water, about 42 degrees, stored in one tank, and we have hot water, about 160 degrees, in another tank. So if we need to cool a building in the daytime, we'll actually consume electricity to run a pump and circulate that 42-degree cold water around campus to cool buildings. Likewise, the hot water, if we need hot water for heating or showers or cooking or laundry, we'll use electricity to pump some of that hot water through our piping loop around campus to the buildings, and they'll take the heat they need for this.
Oh, so the water is, the temperature of the water is key.
Yes.
And in some cases, you're using hot water to warm buildings.
Yes.
And you might be using the hot water to create electricity to cool.
No, the water does not generate any electricity. It just supplies heating and cooling to the buildings. All of our electricity is generated either via our solar panels on our campus roofs. That's really only about 3% of our total electricity. And the rest comes from the grid, about half from our new grid solar plants in Southern California, and half is just general power from the market.
Okay, so you helped me, but I'm just going to repeat.
Sure.
So the hot water that you have in your tank is distributed out to the buildings to provide heat.
Yes.
Because the water has heat in it.
Yes.
And the tank that has cold water, the water is distributed out to places where you want to chill.
Yes.
Oh, that's very interesting.
So you might have a data center, a building full of computers that you want to keep cool. So it might be using some of that 42-degree cold water we're sending out to keep those computers cool, whereas next door in a residence, they might need hot water to cook or do laundry. They might be taking some of the hot water from our piping system at the same time as we're delivering cold to others.
Okay, you have been very helpful to my audience, I think, and to myself. And, you know, for our part one of the interview, we are running out of time. But when we start up again, I really would like you to help us understand why people call you the leader in this type of energy, climate, heating. Okay.
Sure.
Hi, I'm Michael Killen. My guest was Joe Stagner. And please tune in to the part 2 of this event. And you'll find it up on YouTube. Teleview and Connect broadcast this all over the nation to TV stations. If you're a TV station, you can go to Teleview and get it, or you can go to pegmedia.org and get this show. Again, I'm Michael Killen.